Let's get going. So welcome everybody. Thank you so much for joining this Mainframers event. This is Containers on Z. So thank you so much if this is your first time being part of us, and for those that have been on this journey over the months and years, welcome back. You're very welcome. So just before we got started, I was having a look back at how long we've been doing this. We started back in November 2018, and this is actually our 23rd event now, which surprised me. So we're running about 3 to 4 events a year, and we're really excited to be bringing this to you on the theme of Containers on Z. So my name's Matt Comer. I'm an IBMer, and Mainframers is an open community made up of all sorts of different people represented from IBM and companies like Broadcom, BMC, Rocket, and other companies. So without further ado, in terms of the agenda today, so I'm here just to give a quick intro, and we're going to have an icebreaker to get things started. And then excited to say we've got 4 really exciting presentations to bring you. The first will be May Saron, giving an introduction. It's a really fun talk on containers and Kubernetes. We'll be hearing from Sujit Neb, who'll be talking about a containerized Python app running in ZCX. And then we have Dipesh Rawat. He'll be talking about the ZOS container platform. That's of particular interest to me because Dipesh works closely with me in the team that I'm part of in IBM. And then also pleased to say we've got Andrew Smithson talking about containerized ZOS Connect. We aim to wrap up no later than 7:30 UK time, so that's just less than 90 minutes from now. And if we have time, there'll be a chance for Q&A at the end. So what is Mainframers? I've given a little bit of an intro. We started back in 2018. It was when Meetup was, the Meetup platform was quite a big thing, and we thought it'd be a really good way at trying to bring in a new audience. We put on free events. We started up in person, so our first 3 or 4 events were in London. What you can see behind the presentation is that first event in London, and then COVID happened, and that made us move to being an online group. And what we quickly found was that we grew from a UK London audience to a much more global audience. And with that, as well as welcoming many of you who are from all parts of the world, it also gives us the opportunity to have speakers from all over the world as well, which is what we have tonight. And that is fantastic to have. And then earlier this year, March was our first hybrid event. We hosted it in London. We had a small team. We had about, 15, 20 of us in London in an upstairs room of a pub in London. But it was a hybrid event, also live online, and with some of our speakers were from the US and around the world as well. So we try and run, about 3 events a year. Sometimes we have themes. Sometimes we have an open mic event. We've done quizzes. And our aim is to be fun, informal, collaborative, and we're always open to new ideas as well. So we'd love to hear your feedback. During the event, there's the chat, and after the event, there's a feedback form. We would love to hear your thoughts. So this is a few of us. I'm on that left-hand side. We've got Stuart, who'll be doing the icebreaker in the moment, is in the middle, and we're a crazy bunch of people. To find out more about us, I don't know how you've heard about us today. It might have been through Meetup. It could have been through Slack. It could have been through LinkedIn. We are present on all those sites. You can find out more there. To get involved, we, being an open community, we love to have more and more people being part of the team. So if you're interested in being part of the team, in helping this thing run, please get in touch. We are very open to new people. We have a planning meeting every 2 weeks. It's just a 30-minute meeting, and it's quite light touch in terms of the effort for making these events happen. In terms of opportunities, you can be part of the organising team. We're always looking for new speakers. So if that's something you've got an expertise in a certain area and would like to speak, please get in touch. And there are other ways of being involved as well, like it could be hosting, like what I'm doing, and you can probably do a better job than I'm doing here. So without further ado, before we move to our first presentation, Stuart, over to you.
Thank you, Matt. So nothing sophisticated here, just going to ask some fun questions. You know, there's no prizes, but it's a little bit of an icebreaker to get people before we get into the deep technical stuff. One of the reasons that we put this event on is that containers are a rising use case for the mainframe, with organizations recognizing how valuable the platform can be. And there's a lot of people that bandy around some terms. So we just wanted to introduce a few of the terms, few of the products that are involved in the icebreaker. So let's get into it. We're going to use the chat. We just answer from your keyboard A, B, C, or D, depending on the question. So let's have a go, Matt. Let's have the first one. So A, B, C, or D, which of the following is not a potential benefit of containerization? So would you say portability is not, isolation is not, scalability is not, or monolithic applications is not a benefit of containerization? Okay, so lots of people in the chat are going wild with my average grades at school. So Matt, if you want to go on with the next one, yes, you're right, your D's, monolithic applications. So, right, which of these product names are not involved in container orchestration? So Docker Swarm, Kaneko, Kubernetes, or Rancher Labs? Okay, there's a swarm of bees coming in through the, that's it. And Kaneko is actually used, that was a tough one, because that's actually used to build Docker images, whereas the others are used for orchestration. And that's really quite an important thing that we wanted to get people to start understanding the difference between the orchestration and the actual container images. Go on then, last one, Matt. So K8s, it's a term that's banded around. This might be a bit easier, but is it something to do with container orchestration, a boy band from Korea, an electric car manufacturer from China, or a Hollywood blockbuster starring Vin Diesel? So someone's gone for the boy band from Korea. I thought that was quite imaginative. Thank you. Yeah, the right answer is something to do with container orchestration. And apparently in doing the research for this event, the 8 in the middle of K8 is the number of letters that's missing between the K and the S in Kubernetes. So the Kubernetes bit is 8 characters. So if you're ever on Countdown, Matt, and the right combination comes up.
I've learned something new there. That's great. I didn't know that. Brilliant.
Well, that's assuming that the internet is in fact correct, Matt. So anyway, thank you, everyone. Let's get on to some more serious things. So over to you, May.
So, yeah, May, I had the pleasure of meeting May a couple of weeks ago, and it's been so good getting to know her, and you'll really hear her passion coming through as she shares a bit of her story. So I'm going to stop sharing and over to you when you are ready, May.
Okay, I guess that today is the best time to lose my voice. Oh, no. Because and now everyone gets to hear this version of my voice, but I have to guarantee all of the people that are here that this is not my always voice. It's sometimes I have a normal sound voice. But anyway, I'm done talking about that. Let's move over to Yes, let's do this. I shared as you can see the screen, right? Yeah. Cool.
Yeah, that's great.
Okay, so it means that it's now a good time to start the presentation. And I want to say that I am so happy to be here. I handcrafted this talk specifically for this meetup because it's important for me to do the best thing that I can to transfer the knowledge that I have to different communities. So thank you for having me here, and let's begin. So I want to start by telling you about a time where I had 24 hours. And that's exactly all the time that I had and my teammate had in order to create an Android app. And what we wanted to do was pretty simple. We just wanted to do a smart task manager. And because we thought that it's so simple, we felt happy. I mean, we can do it. We're four talented developers sitting in a hackathon. We can win this competition. Yeah, easy. We were so sure of ourselves that even when we knew that all we needed to do is two microservices and one database and just an Android app, it felt like it's a lot, but we were just happy we knew we have it. That we just took the time to take another photo. Why not? You know what this moment here that you see, what it captures? One word. There you have it. Because, I mean, come on, people. You're not that good. And I'm saying that about ourselves because as the hours slipped by and, things started to get pretty stressful because we found ourselves wrestling with dependencies, version mismatches, and configuration issues. You know what that looks like, right? Fun. And so by the time that we got everything up and running, we only had 2 hours left to code. Oh my God. So did we make it on time? Did we get to eat all the good food that they served at that hackathon? And what does all of this have to do with Docker or Kubernetes or both? Well, before I tell you about it, because I did promise to talk about all of that in the title, so I kind of need to talk about these things, but I kind of want to tell you, who am I? So my name is May Baserone. I've been a backend engineer for over 5 years, and today, for the past 3 years, I am a senior platform engineer at Forder. I'm an international public speaker, which means I love to go up on stage in different conferences and share my knowledge. Sometimes I like to talk about functional programming, and sometimes I like to talk about Kubernetes. And I'm also a mentor, which means that I love helping other people become the tech speakers that they can be. And yeah, I'm also a party girl. Wait for it, because I love to join Diablo 4 parties. Woo! One last thing is that I'm a sworn Star Wars fan, and I do have a bunch of Star Wars things here, and a few amiibos from from me playing other games on the Nintendo Switch. But enough about that. Let me give you a little bit background of the company where I work at today. Today I work at Forder, and Forder is a SaaS company that provides fraud prevention in e-commerce interactions. And in order to ensure that our customers can complete their transactions while fraudsters are blocked, we need to do a whole lot of work with Kubernetes. But let's keep that for later, because right now I'm sure that you all want to hear about this. So let's get back to that running clock. I mean, you know what? I think there isn't a lot to say because we had 2 hours left to code, and that's not enough time, especially when you're like a bunch of students. Um, yeah, we didn't. We just failed. We didn't make it, and but we had good food. Did that prevent me from trying again? No, 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 because I just went and I submitted myself to another hackathon. So here's that smile again. And it's the same idea. Two microservices, one database, and an Android app. That's it. I was like, this is just so simple. I can do it. We can get this done this time. And you guessed it. We didn't. Okay. Second time, failure. This, maybe I should start taking that hint. Did I? Nope. Because two failures did not stop me from trying yet again. And when the next hackathon popped up, I signed myself back in. And this time, I knew that I wanted to do something different. I wanted to create a game. I was like, okay, maybe it's not just the setting. Maybe also the app itself is kind of boring, like a task manager. I don't know. But I knew that I definitely can spend the entire 24 hours or even 20 hours on setting up the environment. And let's try to think about again on what I had to do, because I had a lot to do. Set up two microservices, it's not a small task. I needed to ensure that they can talk to each other seamlessly, which involve dealing with network configurations, port binding, and service discovery. Also, having a database, that's adding another layer of complexity. And then there was the Android app, which required its own environment and emulators, SDKs, and Gradle builds. I only had 24 hours to do that, and the clock was ticking. And again, this time I was not going to let the time slip by. And just at that, as the minutes went by, I remembered that someone at work mentioned something to me. It was a weird name, Docker. You guessed it, kind of obvious. It was in the title. So it was back then, it was a not new, but still magical to me, tool named Docker. And it wasn't just Docker that I'm going to say how it, helped me at that hackathon. It was also Docker Compose. I was so curious and desperate, to be honest. So I dived into the documentation, which felt kind of weird to do in a hackathon. But still, that's, that was my only chance. Everything else that I tried to do kind of failed. So let's take a look at what we have here, because every single Docker container, it begins as a pure vanilla Linux machine that basically knows nothing. But then we can tell the container, we can write a configuration file named Docker file, and we can tell it everything that it needs to know, the dependencies, and maybe what is the command that is going to be run when the container starts. And so this enabled me to be able to create separate 3 different environments, and it will always be the same when I run it on my machine, when I run it on my friend's machine. So let's take a look at what it actually looks like in terms of the architecture. So over here we have the developer, me. I'm writing some Docker file, and then from that I can create the Docker image. But that's not the thing that is actually running, because when we run that Docker image, what is created is a container. And this is where the magic actually happens, because the same container can be run in the same way on my machine and on others' machine. Let's take a look at a small example of a Docker file. And I mean, generally most Docker files will look like that. I mean, okay, you can say, no, I've seen a Docker file that looks different. Good for you. This Docker file is here for, as an example for those who are not very familiar with the Docker files. So over here we can see that this Docker file specifies the operating system that will underlie the container, along with the languages, the language, which is Python in this case, and also some environment variable, file locations, network ports, and any other component that it needs. And of course, what actually will be done once we start to run it, which is the command that you see all the way in the bottom. And look at this magic, because while Docker allows me to create one container, I can create a few Docker files and then put all of them into one Docker Compose. Because if you all remember, I said that I needed 2 microservices and a database. And now if I want to have all of this environment set up on my machine or on any other machine fast, all I need to do is create a Docker Compose just like this one. So over here, you have another example of not a Docker file, but a Docker Compose file. So once we have the Docker files, we can reference them in the Docker Compose. And as you can see over here, I'm defining 2 microservices, the ports, and a database, and even my Android app. And this was just the blueprint that saved my life, because look at this smile. I mean, it took some time for us to configure it, but 3 hours later, we had that blueprint of our entire environment. Each of us was able to work on their own part and be sure that there won't be any inconsistencies or anything weird. I mean, for the most part. And I mean, we kind of got rid of the it worked on my machine situation. And when I say kind of, I mean, it's never totally out of the question, right? So I'm sure you're all curious what we created. So here it comes. Oh, bam. By the end of this night, we had this fabulous game up and running. And yes, we named it Calculus. Remember, we were, and we just graduated college, some of us, and some of us were still fighting their way through that very difficult software engineering degree. So let's take a look at a video of the actual game that we have over here. So I clicked on the plate. Is it okay? So what you see is a is a poor student. It's not the best game you've ever seen in your entire life, but I'm still proud of it even today. And what's happening in this game, and I feel like I need to explain because it's so complex, is that this student is trying to avoid the calculus tests, and every time that there is a collision, the student is being pushed outside of the class. And I mean, I feel like I'm explaining the joke, but also laughing at my own joke, because what's going to come now is that you fail calculus. And the funny thing, at least funny to me, is that there is no way to win this game. Yeah, so we created a game where you always fail calculus. But I did pass calculus, so I had to say it. But it went so well because we had the time to create this game, even create a scoreboard, and everything was so smooth that by the end of this night, ta-da, we won. And get it, what we got by the end of this night. It's gonna be amazing. Look at that big smile that I have there. I still have that smile on my face right now. I got a laptop, and it was crazy. I mean, I didn't have such a good laptop back then, and so winning this was amazing for me. And the feeling that I had inside, that I was able to just get rid of the configuration part of things as fast as possible, and I was able to focus on the development, that was just magic for me. But this is just where the magic started, because we were able to use that same blueprint just for the configuration, right? Not the code. We were able to take that blueprint of just, configuring 2 microservices, a database, and an Android app. And we took that to every single hackathon that we went to. Yeah, that was crazy, because every time we got into a hackathon, we were just able to start, programming. So we went and we wrote more and more games. But the next time that we went to a hackathon, and we created another game, and we were thrilled to see our game up and running. And everything was great. Our game server was running, the database was connected, and the front end was looking great. It was even a better game, better front end than the calculus one. And we wanted to see, like I said, if we can go bigger and do better. And we wanted to try and have more players playing our game. So we actually asked all of the participants in that hackathon to try out our game. And you guessed it. Wanting to grow is nice, but was our setup ready for it? No. Because as more and more testers started to play the game, our backend server began to struggle. And I tried to manually scale our game server and containers to handle the increased load. And that involved spinning up more and more new containers and updating the configurations on the fly. But soon I just found myself drowning in a sea of terminal windows, each representing a different container, and I had to keep track of which container was running which configurations, and I needed to ensure that each one had the right configurations, and that became a logistical nightmare. And again, I found myself in a situation where precious hours just slipped away as I manually balanced the load across our servers. So I wrote here, go home, and that's a bit dramatic because there is another solution. The technology exists. So you guessed it, Kubernetes, yay! Okay, so what is this? Okay, here's like the nice term for Kubernetes. Okay, I'm gonna read it to you because I have to. So, Kubernetes is an orchestration management platform of large distributed systems by automating tasks such as load balancing, scaling, and rolling updates. And when I read it, I'm kind of joking on reading this terminology over here because I felt it in my hands, like how it was just so nice to have Docker, and I was able to, do a bunch of things with Docker Compose. But when I actually needed more and more service, and it wasn't like, tens or hundreds, it was just a few, but it was still annoying. It was still difficult for me to handle alone. And so having such a thing as Kubernetes, where this can handle all of the load balancing by just, all I needed to do was adapt the configurations and one or a bunch of YAML files. That's even more magic. So let's talk a little bit about what's going on over here, because a lot of times I see people just presenting the Kubernetes architecture, and it doesn't say a lot if you just put it out there and you don't explain what are the important parts and what are not important parts depending on your role, because everything is important, right? We need all of it to get everything going, but sometimes the importance depends on what it is that you do. So for me as a platform engineer, I am very interested in the master node, master worker, because I do want to know what's happening inside the controllers. But for developers, it's not as important. For developers, what's more important is the YAML file, because this is where they define what their app needs in order to be able to run on Kubernetes. And then the other thing that is important for developers specifically is the data plane. And this is where the action is happening, which means this is where your application is running inside the pod. So because I don't have a lot of time, and to be more specific, I only have a few more minutes left I do want to say that because Kubernetes has the horizontal pod autoscaler, this could have saved my day at that hackathon. And I kind of did a spoiler here because we didn't get it up and running. We weren't able to configure a Kubernetes cluster in that hackathon, which meant that for us, go big or go home was almost go home, but we didn't go home because we told the judges about what we would have done if we had more time, and somehow they liked it so much that we won anyway. And yes, that's a plane ticket to Tokyo. So yeah, thanks to Kubernetes, but mainly to Docker, I was able to save the next hackathons and win a bunch of them. And maybe one day I'll go back to one of those hackathons and win something else with my magic abilities with Kubernetes. But until then, I'm here to answer your questions. And thank you.
Hey, mate, that was amazing. Thank you so much. Brilliant. So when we were planning the event, I think it was really important that we had someone outside of the mainframe, someone from a cloud distributed background to speak. And you've made something pretty complicated so fun and easy to engage. So thank you so much, May.
Yeah, happy to be here, and I was happy to show that Docker and my calculus game. I honestly every time I always want to present it because I'm still so proud of that stupid game, and I have to say that one time that I was happily discussing this game, and I didn't realize that one of my professors was there, and it was so embarrassing that I was like, haha, you fail calculus every time. And I was like, oh, didn't see him here. Okay. But yeah. So thanks everyone for listening.
Brilliant.
I'm going to stop sharing now. And if you have any questions, you can reach out to me or you can ask now, I guess. I don't know.
So we'll move to Sujit now, and if there's time, we'll go to Q&A at the end. So, but thank you so much. That was awesome.
Yeah, so that was awesome, obviously, because containerization is fun. And now we are going to talk about containerized Python example on GCX. So I'm going to add mainframe part to what the containerization is and why it is important for us to use that in mainframe. So hi, this is Sujit Neb. I'm working as a senior automation engineer at BMC, and I'm going to give very simple form of Python example that is running on GCX. So let's start. Yeah, so in this small session, we are going to talk about a bit Python application and GCX, how we are going to make containerization using both. And then we'll see what prerequisites are there to understand why it is required and what is required to get this going. Then we'll see step by step how it works, where you need to take care of things and things like that. So and then we'll conclude with final word and we'll take questions, as Matt said, like at the end of the session. So I think May already has explained containerization bit, and I have seen that the problem she has faced was first one is like reliability, because she was saying that it was working on her machine but not on friend's machine or some other machine. So with containerization, she must have solved this reliability problem, and that's my favorite also, because it is first and foremost important for us to make our software run equally on anywhere, any platform. Wherever there is a need of scalability, we can also scale up and down. Also, there is a good thing about containerization is portability. So you can just using Docker image, you can just pull and run your container on any machine any number of times with just one run command, which is Docker run. We're going to see that at the end of our demo. And then again, one of the important aspect of containerization is efficiency. So we are just taking I think May also explained in her example, like she has taken like two microservices, one database and one app. So that's how efficient it is. Absolutely no junk, no wastage. Everything is required to be running. A simple application is packaged and bundled together in container. That's how efficient it is. With that, it makes a faster delivery. And you also heard about how faster she was able to make her application live and up and running. So definitely it is one of the good example with containerization. Improved security with the help of container orchestration tools, Docker and Kubernetes and such are providing high security around your containers. So that is one of the important aspect in software development. Again, faster app startup is also one of that she has also explained, and it is I would say it is universal that we would need to have our application running as quick as possible without any downtime. With this setup, it's also easy to manage. So easy management is one of the good aspect about containerization, and definitely flexibility is more important when you scale up and down. So with orchestration tools, you can get that flexibility as well. And there are a number of other advantages about containerization, but we'll cover these like important one. And definitely you must have gone through these problems at some point of your career, and I'm sure that containerization will help you solve these problems as well. Uh, Today, what we are going to solve with this is deploying a Python app on ZOS. So two things are required. As I said like earlier, Python application and GCX, which is ZOS container extension. It is available with ZOS 2.4 release and above. So that enables actually um, you, or maybe it provides a Docker CLI command line to run your containers on ZOS or manage your container on ZOS. And Python application, you can take any type of Python application in terms of deploying on GCX. Here today, we are just going to use simplest form of Python application so that you can at least start with this and then gradually grow. So in this diagram, I'm trying to showcase like how containers are residing within ZOS. There is GCX instance, so you must have GCX instance up and running before you containerize any application. And definitely GCX provides Docker CLI, and hence you can use Docker commands to run your or to manage your containers inside the ZOS. Now we'll see how this works. I'm trying to make this as simple as possible because I know there are maybe new people to this topic, or maybe some like practitioner to this topic. But let's start with the simple one, because some of like me, most of the time afraid of starting because we are not sure about the technology, or we are not sure about how it is being done. So I want means I would like to help those guys like or girls so that they can at least start working on this, and then they can gradually grow and learn more about it. So here let's consider creating a Python application and a Docker file. So Docker file parts already explained by me. I'm not going to again touch base those, but in simple form, I will explain Docker file. And Python application is just a simple HTTP server. Again, it is not a production version of code. It's just for this demo purpose. I'm just displaying the Docker logo and a message like hello from Docker. So this is we are going to run on 8080 port on the local host. So in order to get this Python application containerized, we must create a Docker file in order to create container image. So here today we are going to learn about how to create the Docker image. And with this Docker file, you will be able to create your first Docker image, and you can host your Python application. So here on the left side, you can see that the Docker file contains couple of instructions. Very simple form of instruction. Again, no fancy stuff. It just needs a base image from where it is going to create the container. What things it needs to be done with the run command, then adding the files or whatever things required for your application to run, then setting up working directory, and then command as soon as your container starts up and running. Simple form of command we are going to run once our container starts. So it is going to be running this python.py code as soon as our container starts. Before our container start, we need to create Docker image. So earlier was the Docker file, and with this Docker build command, we can create a Docker image. Here on right side, you can see step by step how it creates the Docker image. So from step 1 to 5, you can see how it reads the instruction and work on that. And then at the end, it successfully build the container image. So it is container ID, and then it also tags your image with the name that you supply. So here you can see that there is a command docker build. It has -t that is tag, and we are specifically tagging this as a Python app server GCX. Just to make it simple in order to manage the server at the end of um, maybe running this, or maybe for from a container management point of view, you must tag your image all the time. You must version it all the time, so that you will not have any conflict with your new created image. So here you can see that I have just created a note. So make sure that your Docker file and app.py file are present in the same directory, so that it reads simplest way and you don't have to rush a lot. So here you can see that there is a directory like pyapp_gcx. I'm just creating list. I'm just listing the contents of this directory, and you can see that Docker file and app.py is present on GCX instance that is running on the ZOS. So once you build the Docker image, it gets you tag and the version, and then you can run the Docker command, that is Docker run, to spin up your first container using the new image that has been created in earlier step. So in order to run the container, you need to provide a couple of options. Here I'm just putting very simple form of, again, uh, simple form of run command. Here I'm running this container in detached form. I'm exposing this to port 8080 and giving our container name as pyapp server container -gcx. And you can see that at the end there is a image name. So here you can see that port is exposed to 8080 and Docker image is used pyapp the server -gcx. So this image was created in earlier step using Docker file. Now we are using the same image to create this container on port 8080 on localhost. So as soon as you run this command, you get this output. So here you can see the big number, which is a container ID. It is created as soon as you run this command, and it then you can test and verify whether it's created or not. So with Docker ps command, it just displays the status of Docker containers that are running on system. There are again different form of Docker commands that you can use to list all containers, to list all images, but today we are just going to see how Docker ps is going to help us to understand whether our Python application that has been created is running or not. So you can see that it was created 14 minutes ago. You can see what command it supposed to run as soon as it starts, what is the container ID, how much, what is the current status, or whether it is up or down. So you can see the status. Ports also exposed, or whatever ports type you have used, and the name. So this is important, otherwise Docker will means always link that to some names, but it is always recommended to use your own name, so that it will be easy to manage those at the means whenever you do the Docker management. So this is means important before we launch our server, because we need to ensure that our container is running before we launch our Python application. So now we have confirmed that our Docker container is running. It is up on 8080 port, and the name is this. So let's see. Sorry. So in order to launch the server, as I said, like it was hosted on localhost, you can do it two ways. Like you have this curl command where you need to provide the localhost, which is a URL to your server, and then the port that has been exposed. So here you can see that the instance is running this command, and it is now displaying the Docker logo and the message hello from Docker. There are chances like you might have your GCX instance with IP address set, so you can also do that way. So curl hyphen or maybe space provide with IP address of your GCX instance and then 8080 or the port of your choice. So make sure that you give this command properly, so that you will be able to run the application and get the output. So with this, you definitely did your first example, and you completed it using like simplest Python program running on GCX instance. And I means it's very famous quote again, it always seems impossible until it's done. So I recommend everyone to um, take the first step and start using GCX for any of your Python application or any other language application. So it will be easy and very user friendly as well, and definitely it will save some time of your daily routine. And if you want resources to get this started, I have provided this link, or contact me on this email or LinkedIn page, so that I will be able to answer your queries. And yeah, thank you for joining.
Thank you so much, Sujit. That was wonderful, brilliant. There's some really good conversations starting on the chat, and unfortunately, we're not going to jump there just now, but because I feel we may overrun. But what we will do is we'll try and come back to some of these really good questions at the end. So
Yeah,
please keep asking your questions, and other people do feel free to jump in on the chat. But let's move straight to Depesh, who is up next, and who's going to talk about the ZOS container platform.
Only people can see my screen.
We can see your screen. It's blank at the moment.
Yes, it is on purpose.
Great. Then you are all good to go.
Okay. So hello, everyone. So it was nice listening to May and Sujit regarding containers. So I'm going to build on top of what those guys were talking and introduce to you guys about the IBM ZOS container platform. So hello, I'm Dipesh. So I'm a software developer. As Matt mentioned, I'm one of the developers who was part of the ZOS container platform team in developing this product. And I'm also a maintainer in the Kubernetes community. So before we dive into what is ZOS container platform, let's take a step back and understand how the applications are developed over times. So initially we used to develop applications on our machines, which were running fine. But then we were running into problem that this application works on my machine, and when I try to run it on other machine, it does not run, which is a classic excuse. Then came the virtual machine. So what virtual machine is doing is we are running a guest operating system on top of an operating system we already have. And then we configure our application on top of that guest operating system. And then we run that application. Again, this was kind of working, but the problem was this is it was causing a strain on the host operating system as you are running a entirely new guest operating system on the existing operating system using hypervisor. And then came the containers. So what containers did is it decoupled that guest operating system and the need for hypervisor. Instead of that, containers are basically it's just application, and the libraries and the dependencies your application uses, it is encapsulated in that. And then there is a container engine that enables to run those containers on any machines of a particular architecture. So this is how the application deployment evolved over the years. Now, where are containers today? Now, broadly speaking, there are these 4 types of containers, which I have listed. This is not an exhaustive list. There can be several based on the flavors and the architecture in the machine you are using. So for today, let's assume that these are the 4 levels, 4 types of containers that we have today. So first is the x86 Linux containers, which is the classic container. So when people talk about containers, they are mostly talking about the containers that run on Linux. So these are applications that are compiled to run on x86 hardware. And these are classically run on Linux operating system, exploiting the features of the Linux kernel of isolation. So next is something that is Linux on Z containers. So these are applications that are compiled for S390X hardware, but these are configured to run on Linux on IBM Z. Then we have ZCX, which Sujoy showed in the previous talk, that these are again Linux on Z containers that are running in a ZCX appliance, which is running in a ZOS address space. So still you are running Linux on Z containers, but then you are running it on ZCX appliance that is running on a ZOS address space. Then there is Windows containers where applications are compiled for Windows kernel, and then Windows underneath uses virtualization of Linux to enable those Windows containers. So if I draw a chart of all those containers, types of containers we have right now, it would look something like this. We have containers for Windows, we have containers for Linux, and then the deployment option where those containers are deployed. So with ZOS container platform, what we are doing is we are introducing a third type of container. So this containers are meant to be run on ZOS. These are for architectures S390X. And instead of running on a Linux on Z system or a ZCX appliance, you are able to run containers natively on ZOS. So this is what we are introducing with IBM ZOS container platform. Now the question arises, why are we doing this? So basically the two things in our mind was tools and skills needs to be aligned across organizations. So as containers are getting popular, there are a lot of new graduates or new developers that are taking up these skills. And we wanted to use those skills for mainframes and for ZOS. So with the skill consistency in mind, we get a few other points as an add-on. For example, standardization, because with containers, the good thing is that it is transportable across all the environments that it is built for. For example, if I have built a container that is running on my x86 Linux machine, if I give you that container image and you run it on your machine, it is going to run. So the transportability comes in out of the box. Then in terms of agility, so container supports a lot of agile practices like DevOps, GitOps that we like to hear about. And they make the time to development shorter, as you can spin up containers and tear them down very fast. In terms of orchestration, the problem with containers is if you're running 1 or 2 or 3 containers, it is fine. You can manage those containers. But in a production system where you can run thousands and thousands of containers, for example, I'll tell you. So I guess most of you had heard about a product that is known as ChatGPT by OpenAI. So the backend of ChatGPT is running on a Kubernetes cluster. So that Kubernetes cluster is running approximately 3,500 nodes that are managing all those services that you get to see and chat on your server. So container orchestration using Kubernetes is a very powerful tool. So when we enable containers on source, we get to do that also. And then in terms of overall quality improvement, so ZOS by itself is very secure. So with container on top of it, we are adding another layer of security on top of it. So how are containers going to look on ZOS? So just to inform you, these are going to be same as what you run on Linux or in any other machine. So it is basically just your application that is bundled in with your config, the dependency, and any monitoring endpoint you have. So the container file that May showed and Sujoy showed, that is the Docker file, is going to look, the syntax is going to look exactly the same for running containers on ZOS. Now containers, if I go into a little bit of technical detail, how containers are enabled. So containers use the underlying kernel features that Linux provides in terms of namespaces. So on a very high level, containers are nothing but isolated processes. So these are independent processes that are running isolated from each other. So this isolation on a classic Linux container is provided by something known as namespaces. So there is a process namespace, there is an inter-process communication, there is a UTS namespace, there is a mount namespace, there is C groups, and so on and so forth. So to enable ZOS containers, we had taken the inspiration from all those and implemented it into the underlying ZOS. So why I'm telling you these all details? So when I'm telling that you are able to run ZOS containers natively, it sounds that it is very easy, but underneath there is a lot of invention and lot of work that the team has been doing to enable those. So with ZOS containers, you can think of an example that there is a 20-year-old mission critical COBOL application that is running in Kix and IMS, but now it can be with the help of ZOS containers, it can be modernized and we can use Kubernetes as an orchestration platform to manage and scale those applications. So, okay, so containers on ZOS is very good. So what happens to the users now? So there are basically, I'll say two users, system programmers and developers. So for system programmers, their usual work does not change as is setting up the environment for running the application, providing developers with the platform or configuring their environment. These does not change, but they will have additional responsibility of creating images. So these images will be regulated by them as to what configuration they are running, how much resources they are consuming. So they'll create those images, and from the developer side, they could consume the images that the sysprog has made for their environment. So this is ZOS containers. Now the problem, as I said, running 1 or 2 container is fine. Now we have multiple containers. So the problem is, how do we manage those containers? So with ZOS CP, we are providing a container orchestration using Kubernetes. So Kubernetes, what it does, it helps you to manage all the containers that are running into your system. So there are configuration in terms of YAML, which you can supply to Kubernetes, which it can read those YAMLs, and based on what you have requested, it will deploy your application. It will scale your application on demand. It will bring down your application. So it's a very powerful tool. So you don't need to manually go and see each container and configure them individually. So coming on to ZOS container platform. So how did we approach this problem? So instead of creating separate tools for ZOS, what we did is we took all the open source technologies that was already present and we tried to port them on ZOS. So why we did that? So the skills that are the cloud native skills are transferred to ZOS also. So the syntax will remain the same, provided there is some caveat that some things which works on Linux is not going to work on ZOS because it does not make sense on ZOS. So when we did that, so there is 2 specifications. So there is specification for the image, as is how you are supplying your container image, and there is specification for container runtime. So we are following both these OCI specifications. So in terms of open source technologies that we are bringing to ZOS, first is the Kubernetes. So as I said, it is a container orchestration platform for managing containers. And just for your information, Kubernetes is one of the largest open source project in the world. It is not the largest, so maybe it could be a question for next icebreaker, which is the largest open source project in the world. But it is the largest open source project which is written in Golang. Next is a Cryo. So Cryo is a community-driven container engine. So previously Kubernetes were very coupled with Docker as to using Docker as a runtime. But later in 1.24, the community realizes that this dependency needs to be decoupled, and then they decoupled, and there are few runtimes that we get. Cryo is one of those that we have adopted. Then is runc. So runc is a very low level container runtime that actually runs those processes and containers on your system. And then is Podman. So Podman is basically another tool that is used in the open source world to create those images. So Podman we have ported to ZOS so that you can build images that are specifically for ZOS. So in terms of how the components for ZOS container platform look, so broadly, I could say I can classify the core components into 3 types. So one is the set that is used for Kubernetes, that is container orchestration. Next set of tools are image management tools, and next is the container runtime tool. So if I talk briefly about the Kubernetes piece of tools, so these are the CLI tools that the open source community uses. So we have ported them on ZOS, so you can run these tools natively on ZOS to talk to your Kubernetes cluster. So there are 2 utilities here. You can see CAM and kubeadmz. So CAM is a in-house Unix command line utility that we have provided to talk to your control plane. And kubeadmz is similar to kubeadm we have on open source world, but it is catered to for the ZOS platform. So why do we need CAM and kubeadm? So the Kubernetes control plane is not running on ZOS as is. So it is running inside an appliance that is ZOS control plane appliance. So basically it is a Linux appliance inside which the Kubernetes control plane is running. And the CAM and kubeadmz are the 2 utilities you can use to configure and talk to those appliances. Next is the image management tool, that is Podman, used to create images, Scopio to interact with the registry, to push and pull images, to verify the signature of those images. And Emoji is again a very low level tool for building images. Then is the container runtime, that is the CNI, Conmon, and runc. It is same as what we have on the open source world. Along with these components, so we have provided a set of container images for you to make a head start. So what are those container images? So these are Java images, Go images, a base JOS images which you can use to build your application on top of it. So coming on to how the Kubernetes orchestration piece will work in JOS CP. So as you can see here, we will have a JOS system. Inside the JOS system, there will be a Kubernetes cluster that is running. Inside the Kubernetes cluster, as I said, the control plane is going to run under the JOS control plane appliance, and you are going to interact using kubeadm-z. When you are interacting with the actual control plane of the Kubernetes, you don't need to use the special CLI tools. You will use the normal kubectl to talk to the API server, and the API server in turn is going to deploy the container or the applications you have on your worker nodes. And with this Kubernetes cluster in place, we have APIs or monitoring endpoints that use the existing JOS services. So for example, workload manager can be used for determining how much resources you need to allot to your container. So we have given the ability to supply a WLM class, and based on that class, you will get the amount of resources that is getting allocated to your containers, so on and so forth. So as you can see, we are basically marrying the best of both worlds. As in, you are getting the power of Kubernetes and running containers on JOS, as long as you are getting all the goodness that we already have on JOS systems. So good, now that we are able to run containers on JOS and we can use Kubernetes to orchestrate them. So what are the use cases for JOS CP? So one of the popular use cases with containers is a DevOps pipeline. So what it basically is, you have your code or your configuration that is lying around in a that is lying around in a source code management system. So as soon as you make certain change to that code or configuration, that triggers a build. So what that build is going to do, it is going to take your change configuration, and based on a container image, it is going to build an image based on your change. And that image is then deployed into a running Kubernetes cluster, and then you can test your application, and then this cycle continues. So basically with JOS CP, you are able to implement a use case like this if you wish so. So on a high level, what use cases do we see? So first, as I said, is for development and test isolation. So containers are pretty much running in isolation. So you can imagine that you need to test a new feature, but that new feature you need to test without disrupting the other applications or the other users on your system. So you can spin up a container for yourself, test those new features, and then promote it for test and production and so on and so forth. The next is we are looking to modernize those. Now, as I said, that we are providing certain images like Java images and Golang images, so that these can be a starting point. So all your applications that are running on USS can be containerized. And there is a JOS Connect image, which I guess Andrew is going to talk about in his talk of containerizing JOS Connect. So with JOS Connect, you can exploit the APIs and then talk to your application and services. So you will get an end-to-end benefit of the container. And the long shot is once you started adopting containers and embracing modern technologies, then we can look to scale those so that those become robust and reliable, and that it can be run in production environments. So here is one scenario. So similarly to how May was showing her Docker file of creating from a Python image. So for example, now I want to create a J2E compliant app. So you will use the JOS image. So the syntax for the container file or the Docker file is going to be exactly the same. So you are going to write something like from JOS base image. Then you are going to use the Liberty layer, which we have, then the JavaScript layer. Then you want to put your application on top of it. So what containers provide is a union file system. So that the union file system which the Linux containers provide is same what you are going to get on JOS containers. So once you have this image, you run this image, you get your application that is running in a container. A second example could be You use the base image, ZOS base image, you put Python on top of it, and then you put your application. And then again, it'll be a union where the first layer is the read-write layer. And then you run the Python application as a container on ZOS. So this is well and good that you are able to run the containers. So for production system, as I mentioned, you will require multiple containers, multiple clusters. So that goes into the realm of high availability. So how do we achieve high availability with ZOS CP? So to build high availability cluster, there are configurations which you can pick and choose. For example, here I have shown is there is a sysplex with three LPAs. So you are running individual ZCP on top of it, and these ZCP will be configured as a high availability cluster where your sysplex distributor is going to act as a load balancer, and the request that you send to the Kubernetes cluster is going to be balanced. Now, it does not mean that your helper needs to have both the ZCP and the Kubernetes worker node running on top of it. You can choose to run your Kubernetes worker node on a separate helper without needing to run the control plane. So this is how the high availability cluster scenario is going to work if you wish to choose so. So let's talk about in terms of rollout. So the first phase of ZOS CP is live. So with the first phase, we are targeting Unix-based application, as I said, so that people get familiar with it, and you can define processes from promoting your applications from dev to prod to test, so on and so forth. So we are providing a bunch of images for you. That is ZOS Connect, Java, Golang, and Python. But the future vision or the end game is to be able to containerize traditional middleware application like Kix and IMS. But that is something that we have to build gradually as the technology matures. So if I talk about the date, so earlier in Q1, we announced ZOS CP that was on March, and it was available on 15th of March. So with the first drop, we just enabled the image building features and the containers. So that on the 15th March or the first GA release did not have the Kubernetes orchestration piece in it. But last week we released the second iteration of ZOS CP that contains the containers and the container in the Kubernetes orchestration that I just showed you. So you are able to run all the end-to-end containers and manage them via Kubernetes. So just to summarize whatever I have said in one slide is, we have a ZOS container platforms, which is built on open source technology, which enables us to bring open source tools like Podman, CryCTL to ZOS. There are a catalog of images that we provide on IBM Container Registry for you to start. Those images are a ZOS-based image, a Java image, a ZOS Connect image, also a Golang image. Then we have a comprehensive documentation that is present in this link if you wish to choose so. And as I showed, there is automation and monitoring capability to hook into existing ZOS services. So with this, I think I have reached the end of my presentation. And just as a challenge, I will throw it to May that next time she comes speaks to this forum, she runs her calculus application on ZOS.
Brilliant. Unfortunately, May's had to drop, but she is keen to have a dabble in the mainframe. Thank you so much, Depesh. There's plenty more interesting conversation going on in the chat as well. There were some questions about IMS and Kix, and just to be clear, as Depesh has shared, in what is currently supported in ZOS CP are applications that can run in Unix system services. So it supports Java, Golang, and it goes as far as ZOS Connect, which is what we have next, the next topic. To support the larger middleware like Kix and IMS is part of that future direction, but there isn't the support for that yet. So let's move straight to Andrew. Welcome, Andrew, and thank you for being up to share.
Well, thank you very much for having me, Matt. Good evening, good afternoon, welcome everyone. My name is Andrew Smithson. I'm the architect for ZOS Connect, based out of Hursley, and I've been working on this product since it came into being. Just as a very high-level introduction, ZOS Connect is a product from IBM that's all about exposing and enabling mainframe applications hosted in Kix, DB2, IMS, and making them available as open API-defined REST APIs that then can feed into part of the API economy. They look like REST APIs that are everywhere else these days, and being able to access those REST APIs from those Kix applications and the IMS applications. And I can spend hours talking about how we do this in ZOS Connect, but that's not the point of this presentation. The point of this presentation is what we've done with ZOS Connect and the support for containers. And when we shipped support for the latest Open API specification, we did a whole bunch of work around reorganizing and re-architecting the product. But one of the key things that kept coming up were things around about scalability, availability of APIs, moving APIs between different environments and making sure they were consistent. How do we build into a consistent modern DevOps pipeline? And the answer to a lot of these kind of questions came up, and it was, oh, we use a container runtime. As the previous speakers have spoken about, that all those features and capabilities come from running your applications and things like that inside a container. So that's what we did with ZOS Connect. And I've been working with the ZOS Containers team and Matt and the person of that team for 4 or 5 years, kind of pre-COVID times, around getting containers onto ZOS around this stuff. But we started off with a Linux image, and that ran on Linux on Intel, on the kind of AMD 64 type clusters, and on S390X Linux. So it would run on a Linux on Z, LPAR, or it would run in a ZCX appliance, as we were shown earlier. But ZOS CP has come along, and there are advantages to running ZOS Connect on ZOS. It's kind of there in the name. And we talked about this. We got access to things like RACF or Top Secret, or whichever your security tool is for accessing and managing user actions. We're really close to the backend systems then that you're talking to, but having the containers there really helps, again, as we say, with that isolation and stuff like that. I'm going to drop out of my slide deck because I tend not to do much with slides, and actually switch to what we're going to talk about and actually getting this going, and those DevOps pipelines and stuff that Dipesh was talking about and all that kind of thing. So the key thing with the ZOS Connect is that you need to build an image for your API or set of APIs that you want to deploy and manage as a single thing. And so we do this again, as we've said previously, with a Docker file or a container file. And this is a really straightforward container file that we care about. So we have the base image that we provide, which is our server image. And as a continuous delivery product, we're shipping a new one of these every month. And then we copy in any configuration we need and the API or the APIs that we want to have as part of that image. So we can do that. We can kick off a pipeline. And then we can switch to our pipeline runs, and we can see it running. So, unenabled space logs because it hasn't started yet. But what we can have here is we can have this thing that we're talking about, that all our source code for the API is stored in source control. I'm using GitHub because that's what we use internally for these kind of things. But other source controlled things are there. We then build our source using Gradle, which is an open source, well-known build tool off ZOS. Lots of things are used there, primarily Java, but it reaches out to all kinds of things. But what that does mean is that we don't have a ZOS Connect specific tool for building the things. It's just, hey, it just works in whatever pipeline you want to use. So in this case, I'm using Tekton, which is a Kubernetes native pipeline. So again, all your source code is defined for it in YAML files, and you can apply that and it manages and you can run it and things like that. And you get great isolation and stuff like that. And then with our API built, we can then build the API image as we were talking about. So this is the first thing we're going to do. We're going to pull down that server image, and that could be from the public ICR repository, the IBM container registry, or you could have copied it to a local registry, as I've done here, which means then it's internal to my business or my application. So you've got great control over that. As we said previously, these are all versioned. So a 3081 image, which is a couple of months old now, is different to a 3082. But one of the advantages we get with the containers and the isolation is you can have lots of different versions of ZOS Connect running at the same time on your LPARs because they're all isolated in those container images. There isn't just one big SMP install that you need to update as the security fixes and things come out, and then work out how all your APIs are going to work in that new version. You've got a bit more autonomy within your development teams and your API management teams into how that's going to work. So that's going to take a couple of minutes just to pull stuff down. I'm working at home, and I think my kids are probably thrashing my broadband to get that going. So we'll move on how we get into the kind of the deployment side of things and doing that way. So, we've talked a lot about Kubernetes and how that works, and the key thing that when you hear about Kubernetes, you're going to hear about otherwise is YAML. Everything is a YAML file. YAML has won in that respect. But what it does really mean is that because it is a file, it can be source control managed. And that's really useful because then you get this infrastructure as code type capability. And you also get the ability to manage changes to that infrastructure in the same way that you do for your code. And you get into this kind of GitOps way of working, where your infrastructure and things like that can go through the same rigorous code reviews, checks and things like that before they hit the main branch, as you would for your source code. So in this case, I've got my deployment YAML and the other configuration YAML files that I need for my deployment inside a GitHub repository. And then we can use any of the kind of standard tools for doing this. So this is Argo CD, which is another popular open source GitOps-based project. You can define that GitHub project to Argo CD, and then it looks at all those files that I've got defined in my source control and compares them to what's running inside my Kubernetes cluster. And as we can see here, there's stuff missing and it's out of sync. Okay, that's probably fair. I haven't been building stuff, but I can click sync and we can synchronize. And what that will do is it will then go and take all those configuration files that we have, apply them to the Kubernetes cluster and see what's going on. So if we click into that, we can then see that things are now starting up. So our config manager, our config map is going in there, our service is going to go in there, and the deployment is going to go in. So that's just waiting to start. Again, I think my networking might be struggling a bit. But the key thing that I want to talk about with this is that all the tooling and stuff that I'm using for building and deploying these APIs is running in a Kubernetes cluster actually on my laptop, because that's easy for me to mess around with. But I'm deploying to that Kubernetes cluster that's running in ZCPA and using worker nodes running on ZOS. Oh, and the sync failed. That's interesting. Always good doing a live demo. Oh, we've timed out talking to the cluster. Matt, what's up to the cluster? Let's try that again. We can also do live debug. There we go. It started. I told you my kids were killing the network. But the sync has started, and we've created a configuration map, and that contains my configuration for talking to my Kick system for this particular API. So there we go. We've got my host name and the port of the Kick system I'm going to, and we've put that into a configuration map so that it's not baked into the image itself. And by doing this in the deployment, that same image can move through all my different environments, my pre-prod, my test environments, and talk to different Kix regions while still being the same API and the same image that we're deploying in all those places. We can see what's going on with the deployment itself and the pod that's coming up. So we can see the container is running. That's good. So we can check the logs. And we can see, yeah, it's all started. And we can also see that we are running on ZOS. So this is ZOS Connect is registering with ZOS. So this is not me faking it with a Linux deployment. This really is running on a ZOS LMPAR using ZCPA and ZOSCP, as Dipesh showed in the previous presentation. And then we get a nice green heart to show that it's all synced. And one of the things that happens, especially in this Kubernetes deployment, is that we're able to check whether the container is healthy. You know, is it responding to pings on the network and things like that. And so we can close that. We can see that everything is all now happy. We can go to there and reload. And that one then fails. There's always one, isn't there? So that should show that it's going, what is working. And I'm having some network traffic problems, but you know, that is still running. I can show you that there. The logs have come up. It says it has initialized, and now my network's playing silly devils with me. Oh, that's because, why is Chrome stuck an HTTPS in there? There we go. And we can see that that has come back with that API call. We've gone off to Kix. We can show that in the logs as well. So we've established the connection to the host that I talked about in that configuration map, and we've managed to get the information back from it. So that has been running ZOS Connect in containers. And it's kind of like, why would we want to do this? And I think this came up in some of the questions earlier. So it's better isolation of APIs and product versions. That's one of the key things that containers really gives us. If you want to roll out a version 2 of an API, that's a lot easier when you can do things like canary testing and green-blue deployments. And we can talk about those in future things as well. And really that infrastructure as code, being able to source code manage how your APIs and your systems get deployed is really powerful, because then you have the same auditability and checks and validation as you would for your source code going through. Right, I think I've taken my 15 minutes. Thank you very much. I will stop sharing and we can go to the Q&A.
Brilliant. Only you, Andrew, were brave enough to try a demo on us. And you were very good at just keeping your composure as you work through that. So thank you so much. And it's just great seeing some of that modern, those fresh tools and stuff that you were using around that. Back in the back end, we're still heavily in ZOS. It's great to see. So
this has been really one of the cool things with the that is Kubernetes on ZOS, is that any tool or technique that I've had for working with Kubernetes clusters on other platforms has absolutely just worked straight away with ZOSCP and ZOS Kubernetes. It's been really powerful to have that kind of switching between really seamlessly, especially for me.
Fantastic. That's great to hear. Right, I'm gonna go back to the presentation just briefly and play from the current slide. So I'm going to do it in reverse order because I'm aware of the time. We said we'd finish at 7 p.m. UK time, and we're getting close to there. But I appreciate there's been plenty of chat going on. So if people at this stage, I appreciate we've got people in India, we've had May in Israel, there'll be people from time zones advanced from us. If it's late in your time, you're wanting to go, just thank you so much for joining. You're welcome to go at any point. We would love to hear your feedback. There is a survey, if you can grab a picture of that to give us your feedback. We would love to hear more. If you'd like to be involved more, we've put on the chat, there is a Slack group you can be part of. And if you're keen to be part of the team, we would really value you being involved. And if you enjoyed it, the big thing is to spread the word to other people. We've got about 1,300 people as part of the meetup community. Please, if you've enjoyed this, please share it to others and encourage other people to come and join future events. So that's the finishing piece. Please do give us your feedback if you can. But I'm not sure. I know May is no longer with us. She's had to drop. I'm not sure. I think the others are still there. So we'll just pause and see if there's anyone that would like to chat. And also if any of the speakers would like to respond to any of the questions in the chat, that would be really helpful too. So this is me not being familiar with Teams. I don't know if people are able to unmute themselves. If anyone has a question and you are able to unmute yourself, okay, we've got a hand up.
Hello.
There we go.
Can you guys hear me?
Yes, go for it.
Okay. Yeah, great. Andrew, I know my name's Jeremy Wiggins. I work a lot with ZOS Connect and CICS. So right now our typical ZOS Connect deployments usually are concentrated more so in like Postman or like the catalog manager is something that I'm pretty familiar with for testing wise. I am a sysprog, so I don't do much of the API deployments or anything like that. So you were talking more about and I'm still kind of new to this, so I kind of struggle with what containers, what exactly like the architecture of what a container does, and especially when it comes to ZOS Connect. But it looks very promising for a couple situations that we have. So it's more of a direct deployment, and forgive me if I'm all over the place, but it's more of a direct deployment. And is that more so going to be helpful with load balancing in specific regions, or is there going to be a way like those container, like right now ZOS Connect can be routed to one region? And right now we're kind of facing with, we want one region, but also a fail safe, not so much in terms of load balancing, but just typical one region. And if that region were to be down, it automatically routes to another KICS region and resources.
Okay, so there's definitely stuff we can do about that with and without containers. And I think I've posted my contact details in the chat, and I'm very happy to have a chat around that later on.
Yes,
so yes, we can do stuff around that. And yeah, please email me and we can have a chat around that. In terms of with container deployments, it's not necessarily about the, once KICS is containerized as well, then we get into a much bigger conversation around this stuff. But in terms of ZOS Connect itself, if we're deploying through Kubernetes and stuff like that, you've got things like automatic restarts. So as we showed in the demo, it didn't, even though the container was marked as started, Argo CD didn't mark it as healthy until the readiness check had passed. And there's other things in Kubernetes called liveness checks. So Kubernetes on a regular cadence will ping the pod to get a response. And if it doesn't, it'll go, that's probably sick but not dead, and kill the pod and restart it. So it kind of does that automated recovery for you. And as May talked about, we've got you get things like horizontal pod auto scaling, which I think still needs to come to the OS in a more WLM friendly way. But then you can have that, I've hit a massive workload, everyone's hammering my APIs, we'll spin up another copy. And because it's an image and that's immutable, it's exactly the same image, it's just running as a new process. So it's the same API with the same configuration, and it's just going to get routed to separately. So that's kind of the benefits we get. But yeah, please reach out and we'll chat KICS high availability another time.
Absolutely. And is KICS supposed to be containerized in order for ZOS Connect to be containerized?
No. ZOS Connect can run containerized on platform, off platform, and we will just talk over the network to whatever you configure us to. So yeah, it's really independent of anything else that's talking on. So it could be non-containerized apps talking to us in a container, talking to KICS or IMS or DB2 outside of a container.
Wow. And last question here. I'm sorry. Is there a specific? Do we? You used a lot of applications. Your presentation was the first time seeing those applications. Are there specific applications that we have to use in a ZOS Connect containerized environment, or can we use those applications that we've been using? Like I'm typically a fan of the Thunder client, but a lot of developers use Postman or even IBM, the IBM Explorer ZOS Connect plugin. Are those usable with containers?
So the ZOS Connect plugin, no, because that's designed for our OpenAPI 2 runtime, and containers is only available for our OpenAPI 3 runtime.
Gotcha.
But our designer is used for that. But then when it comes to containers and build and deploy, we are trying to be a lot less tool specific. So if you have a set of tools for working with ZOS Connect instances, and then you have other tools within your wider organization that work with containers, we should work with those. And if they don't come and talk to me, we'll work out why there's something weird going on.
Yeah, absolutely. And yeah, I would love to discuss what tools you would recommend as well later on.
Yeah.
Thank you so much.
Absolutely. Yeah. Happy to do that.
Thank you so much, Jeremy. Let's have time for 2 more questions and then we'll close there. Is there anyone else who would like to say something before we drop? There was a question about is ZOS Container Platform free, and thanks for the answer. Yes, it is. It's available through ShopZ. It is a licensed feature, but it's available ShopZ for no extra cost.
Yeah. Hi, Matthew. I'm Arun Ajidan.
Hi.
Yeah. So I work on this ZOS space for a long time, and then curious about containers also. So how do you foresee this ZOS SCP will change the way mainframe mainframe world is working? Or like, say, for example, we have this long array of programs which is hosted on C for multiple domains. Okay. So do you foresee like, okay, those tightly coupled applications move into a microservices space, I mean, into a containers and Kubernetes orchestrated way of working, or it is like this ZOS SCP will be leveraged to host a new set of workloads like AIML or analytics workloads, or this ZOS Connect sort of workloads, which will tap into that huge volume of data which is hosted on mainframes. What do you foresee as a future of future business use case of ZOS SCP?
That is a great question. I would rather not be the person. I saw Matthew was on here. Are you available, Matthew? Brilliant. I feel more confident in your hands than me going at that.
I think Dipesh, during his presentation, outlined several opportunities that we have with the ZOS Container Platform. So both in terms of modernizing the existing applications that you have, or in the case of ZOS Connect, as Andrew was saying, being able to use an existing application, but to be able to deploy and manage that in a new way, using a very rich and extended ecosystem of tools that is expanding beyond the mainframe, those that are familiar to you, or indeed for when the time comes, as we said, right now we've got Java and Go. We mentioned other runtimes like Python and Node. So the opportunities there again to be able to run new workloads on ZOS. So this is very early days, I think, as Matt has pointed out in the channel. So we're trying to open the aperture as wide as possible to allow as many different opportunities to arise. So we don't know exactly what it's going to be, and there may be something that we haven't thought of yet. But we've opened it up, so we think there's a lot of opportunities for running different things on this platform.
Okay, thank you.
Thank you, Aaron.
So this go in line with the Red Hat OpenShift product suite, or like it's a totally separate line which IBM is pushing, because Red Hat is also a partner firm now, right? From an orchestration standpoint. I mean, I'm asking from a product roadmap guideline which IBM has at this point.
I think these platforms are all very complementary. When you saw the demonstration earlier of ZCX, that showed the I believe that was the traditional version of ZCX running Docker there, and there's also an OpenShift version that runs on ZCX for Linux applications. So it very much depends upon what you want to do, the rest of your real estate, and the skills that you have. And so for the time being on ZOS, as Dipesh said, in order to manage the deployments, we have included Kubernetes in the box because we think that is crucial. So at that time, we have a vanilla Kubernetes implementation. At some time in the future, we may have greater integration with OpenShift, but at the moment, we have vanilla Kubernetes, which meets the needs that we have at the moment, and then also provides the integrations that Andrew has been talking about and showed with Argo CD.
Sure. Thank you, Matthew.
Thank you. And one last question, and then we'll close. If anyone has. Gone. Okay, well, let's wrap things up there. Thank you so much. Firstly, to the speakers, you've all been incredible. Thank you, Sujit. It's very late in your day. Thank you for hanging in there with us. The depth, the breadth was brilliant. It's been a great event. So thank you so much. And then to everyone who's joined, thank you for being part of this. We'd love to hear more from you. Do reach out if you've got more questions and you want to be involved. So yeah, look out for more events later in the year. And we wish you a good rest of your day or evening. Thanks very much, everyone.
Thank you, everyone. Bye-bye. Bye for now.
Bye, everyone.